Hello and welcome to my YouTube channel Electrical Hub. Here we are going to discuss about the efficiency of air compressor. This is the part 1 for the efficiency of air compressor. We will discuss about the remaining parts in the part 2. Here we are going to cover some of the topics. The topics are compressor and its type, how to calculate the efficiency of the compressor, efficient operation of a compressor to improve the efficiency, and finally to analyze the leakage in the compressor. I will request you to please like, share, and subscribe my channel. Here we will discuss a lot about energy management. What is the air compressor? Air compressor's main function is to deliver the air at a fixed pressure for different process requirement to operate the pneumatic tools or to transport the materials. It is basically a breathing equipment which take the air from the atmosphere and deliver it at the required pressure. Now, let us discuss about the types of the compressor. There are basically two types of compressor. One is the positive displacement compressor and another is a dynamic compressor. In the positive displacement compressor, we increases the pressure of the air by reducing the volume. So the pressure of the air can be increased by reducing the volume. So it follows the same principle. Positive displacement compressors are widely used in the industries. The main two types of the positive displacement compressor are reciprocating and rotary compressor, while the dynamic compressors increases the velocity of the air and thus it increases the pressure of the air. Dynamic compressors are also of two types, radial and axial. Now let's discuss a little about the types of the positive displacement compressor. Reciprocating compressor. Reciprocating compressor are widely used in the industry. Why? Because their flow output remains constant over a various range of discharge pressure. And secondly, the compressor capacity is also directly proportional to the speed. It is the most commonly used compressor in the industries. Now, let us discuss about the types of the reciprocating compressors. Reciprocating compressors are usually of three types. First is the lubricated and non-lubricated. Second is single or multiple cylinder. And third is the single stage or multi-stage. Lubricated and non-lubricated. Lubricated compressors output here may contain traces of oil, which is generally doesn't happen, but it is considered that it contains a fraction of oil. So they are basically not used for the instrument. For the instrument, the non-lubricated compressor is preferred. And secondly, the lubricated compressor have lower specific power consumption compared to the non-lubricated type because the non-lubricated compressors produces more heat, which is the main source of waste of energy in the compressor. Single or multiple cylinder. Depending upon the capacity of the compressor, it can be of single or multiple cylinder type. But single cylinder compressors are generally air cooled, while multi stage compressors are water cooled. So, multi stage compressors are more efficient than the single stage compressor. Single stage or multiple stage. Single stage compressors have lower output discharge pressure while the output temperature is higher, that is from 200 to 240 degrees centigrade. While the multiple stage compressors have higher discharge pressure and lower output temperature, that is 140 to 160 degrees centigrade. So, the multiple stage compressors are more efficient than the single stage compressor because the amount of the heat generated in the single stage compressor are wasted. Rotary compressors have rotors in place of pistons, so they provide a continuous pulsation, free discharge air, and it has a longer life because there are no pistons. Pistons are replaced here by the rotors. There are basically two types of rotary compressors used in the industry. One is the root blower. Root blower have low discharge pressure from 1 to 2.2 bar, but the screw compressor consists of two rotors within a casing where the rotor compresses the air internally and it is also cooled internally, so they have a range up to 20,000 cfm, that is cubic flow meter, and pressure up to 15 bar. Dynamic compressor. Dynamic compressor works on the principle of centrifugal pump. A small change in the compression ratio produces a remarkable change in compressor output. The major limitation here of the dynamic compressor is that it operates at peak efficiency at design point only. And while there is some deviation from the peak operating point, efficiency also get reduced. There are two types of dynamic compressor. One is axial flow compressor and the other is radial flow compressor. The name is based on the direction of the flow. Axial flow compressors have higher compression ratio and are more efficient. Here, the air is allowed to pass through the rotating blades in the axial direction, while in the radial flow compressors, the airflow is in the radial direction and the air is drawn at the center of its unit. Different compressors have the different capacity. Here we will discuss about some of the types of the compressors used in the industry and their capacity. Let's start with the root blower. Its capacity is from 100 to 30,000 CFM and the pressure is 0.1 to 1 bar, while the reciprocating single stage is from 100 to 12,000 while the pressure is from 0.8 to 12 bar, but the reciprocating multi-stage, as we have discussed before, that it is for higher capacity. Here the pressure goes from 12 to 700 bar. The screw compressors of single stage are of the range 0.8 to 13 kg of the pressure, while the multiple stage have the pressure up to 24 kg, and centrifugal compressors have a wide range of the pressures depending upon the requirement. Efficiency of compressor is based on the two process. First is the isothermal efficiency and the second one is the volumetric efficiency. Isothermal efficiency is equal to the isothermal power by actual measured input power. So actual measured input power you will get from the kilowatt reading of the meter and the isothermal power is equals to P1 into Q1 into log ER by 26.7. Here R is nothing but the pressure ratio P2 by P1 where P1 is the absolute intake pressure kg per centimeter square and P2 is the absolute delivered pressure. Q1 is equal to free air delivered. Volumetric efficiency. The volumetric efficiency is measured as free air delivered in meter cube per minute by the compressor displacement in meter cube per minute. So the compressor displacement is pi by 4 into d square into L into S into X into N. So d is equal to cylindrical bore in meter, L is the cylindrical stroke in meter, S is the compressor speed, while X is equal to 1 for single acting, 2 for double acting, and N is equal to a number of cylinders. Components of compressor. Compressor air system composed of
contains
intake air
intake air
filter,
filter,
interstage coolers,
interstage cooler,
air dryer,
after cooler, air
moisture
dryer,
drain
moisture
traps,
drain
and the
traps,
receivers.
and receivers.
The intake
Intake
air
air filter
filter
is
is
to clean the air
used to
before entering into the compressor
breathe clean
so that
air
it cannot
for the
damage the
compressor.
pistons and valves.
It is the primary
Number two
stage
is the
where
interstage cooler.
the air is clean
Here,
so that
at
it
every
cannot
stage,
damage
the
the valves
air
and the
is
pistons
cooled to increase
inside the
the
compressor.
efficiency of the compressor.
Number two is the
It
interstage
is
coolers.
after cooler
Interstage
is
coolers are
just
provided
the
to
same,
cool the air
but it is
so
the
that there will be a minimum loss due to the heat. Third is the air dryer. Air dryer is
components
used
of
to
compressor.
dry the
Compressor air
air
system contains
and remove the
intake air
moisture
filter,
so that it
interstage
can be
cooler,
used for
after
the
cooler, air
pneumatic
dryer, moisture drain
tools
traps,
like control
and
valves,
receivers. Intake air filter is to
moisture
clean the
drain
air
traps. Moisture
before
drain
entering
traps
into
are
the
used
compressor
to remove
so
the
that it
moisture
cannot damage the
collected
pistons
by
and
the air
valves.
dryer and the air receiver.
Number two
Air receiver
is the
is
interstage cooler.
the one
Here,
which
at
maintains the
every
pressure
stage,
so that
the
there can be
air
a
is
continuous
cooled to
pulsation
increase
free
the
discharge
efficiency
air.
of the compressor.
Here we are going to discuss the efficient operation of compressor. How we can use the compressor efficiently. First is the location of compressor. Compressor is a breathing equipment. So it depends upon the quality of the air intake. If the air is cool, clean and dry, it will improve the efficiency of the compressor. Every 4 degrees centigrade drop in the air temperature will lower the power consumptions by 1%. The altitude of a place has a direct impact on the volumetric efficiency of the compressor, and the compressor at the higher altitude consumes more power than the compressor at the sea. Cooling water circuit. The cooling of the air or the interstage or the aftercoolers depend on the quality of the water, its flow and temperature. For inadequate treatment of the water can lead to the increase in the TDS, that is total dissolved solid, which can turn to the scaling of the cooling area. So it will reduce the cooling of the water, and it will also reduce the efficiency of the compressor. Efficacy of inter and after coolers. Actually, the temperature of the air should be same at each stage. It is known as the isothermal cooling. But since that is not possible practically, so intercoolers and aftercoolers are provided to cool the air. So with the variation in the cooling or due to the rise in the temperature, there is approximately 2% change in the power consumption. Every 5.5 degrees centigrade temperature rise will cause an increase in the consumption by 2%. Optimum pressure setting. A compressor should not be set at any high value. For example, if you have the requirement of 6 kg of the pressure and you are setting the value at 8 kg pressure, it is unnecessary losses of compressor because for every 1 kg of the reduction in the pressure of the air, the power consumptions reduces by 6 to 10%. We should also segregate the low and the high pressure air requirement because it will help in improving the efficiency of the compressor. Minimizing the pressure drops in the airlines. Pressure drop should be minimized. It depends upon the quantity of the air, length of the pipe, diameter, its geometry. But in the industry, at the mean header, zero point 0.3 bar and at the farthest end, zero point 0.5 bar pressure drop is only acceptable. We should use blowers in the place of the compressed air for the purpose like cleaning or any other unnecessary activities because the cost of the production of the compressed air is very high compared to the power cost of the blowers. Efficiency of the compressor can be controlled by controlling the leakage of the air. The leakage of the compressed air cost can be from 8,000 per year to 4 lakh per year. How to measure leakage in the compressor? The compressor leakage can be measured after stopping the operation so that no air can be used in the operation. Then we should measure the time for loading and the time for the unloading. So the percentage of the leakage will be time for loading by time for loading plus time for unloading into 100, and the quantity of the leakage will be time for loading by time for loading plus time for unloading multiplied by the compressor capacity in meter cube per minute. I have shown here one example. You can go through that how a small leakage is affecting the cost. You can see here the compressor capacity is 40 meter cube per minute. So loading pressure is 6.8 and loading pressure is 7.5. Loading load is 188 kilowatt and unloading load is 54 kilowatt. So if you will see the calculation, you will find the power lost due to the leakage per day is equal to 564 kilowatt. Accordingly, you can calculate the amount depending upon the price cost of the power at your location. Thank you. Please like, share, and subscribe to friends. Take care.